Okay, let's talk about degrees and radians of the unit circle. We'll talk about unit circle later, but let's just understand what degrees are. So first thing, we have a circle. And as most of you know, a circle is 360 degrees. So when we are doing trigonometry, we're going to put 0 degrees here, always here. This is where it starts, and we go in a positive direction, positive degrees in the counterclockwise direction. So if you start here at 0, well, one time around the circle will give you 360 degrees, and you end up back in the starting place again. So, which means that halfway around the circle will give you 180 degrees. So that's half a circle is 180 degrees. So half of that will be 90 degrees. So each quadrant is 90 degrees. 90 here, 90 here, 90 here, which means 180 plus another 90, that's 270 degrees. And then another 90, then you end up at 360. So when we are doing the circle, we have a couple of special markers that we're going to use, and we'll cover that later. But halfway between 0 and 90, that would be 45 degrees. So we will do increments of 45 degrees. So 90 plus 45, that would be 135. And then 180 plus 45, that would be what, 225? And then 270 plus 45, or 360 minus 45, that would be 315. And then we have also another special increment, which would be increments of 30 degrees. So 30 is definitely between 0 and 45, right? So it's a little bit closer there, 30 degrees. And then 30 plus 30, that's 60 degrees. And then another 30, that's 90 degrees. Another 30, that would be 120. And then another 30, that would be 150. Another 30 is the 180. Another 30, that would be 210. Another 30, that would be 240. Another 30, there's 270, another 30, that would be 300. And then another 30, that would be 330. And then plus another 30, that's 360. So that's how we will break up the circle in increments of 30 degrees, 60 degrees, 45 degrees, 90 degrees, or 180 degrees and 360. So those are the important markers: every 30 degrees, every 60 degrees, every 45 degrees, every 90 degrees, okay? Now let's go look at radians, which are a little bit more difficult, but I'm gonna explain that to you. They're a little bit more complicated. So let me go find my radian circle that I already made. Okay, where'd it go? Okay. All right, radians are a strange concept, so I'm going to draw you a little bit of most people don't think intuitively in radians, so I'm going to draw a little circle over here, a circle with a radius on it. That radius right there, a radian is the same length on the outside. It's based on the outside, the length of the circumference. 1 radian is the same length as the radius. So it's approximately like that long. And what you find is that you actually have, how many radians? 6 radians, a little bit over 6 radians. 1, 2, 3, 4, 5, 6, and a piece there. Okay. So if your radius is, let's say your radius is equal to 1, just for that sake, this would be just for, demonstration's sake, so you can have some concept of that. Your radius equals 1, that would mean you have about a circumference that's just approximately a little bit over 1, 2, 3, 4, 5, 6. 6 plus a little tiny bit there, right? So now here's another way of thinking about this so you can make some sense of that. The circumference that you know from geometry is 2 pi r. And if your radius is equal to 1, 2 pi times 1 is just 2 pi. And what is pi equal to? 2 times 3.14. That is approximately equal to what? 6.28. Just a little bit over 6. Okay, so again, a radian is the same length on the outside of the circumference of the circle, the arc of the circle, as the radius. It's an odd way of thinking about it, but the radius length and this arc length here are the same exact length. And there's approximately just over 6 of those radians on the outside of any circle. So now that we know what a radian is, a radian, when you see radians, they are in terms of pi. So radians also start with 0 here, but this is not degrees, so you just write 0. And most of y'all know if you go 1 time around a circle, that is 2 pi radians, 0 to 2 pi. So now I'm going to subdivide the circle up into different radians right now. And we have to know both degrees and radians. So this is where people make mistakes. I think you're going to see this right now, but logically, what people think of is in wholes, like one whole circle. People like, oh, it's pi. No, one whole circle, 1 time around the circle is 2 pi, which means a half of a circle goes from 0 to pi. That's halfway around. Okay. So 0 to pi, and then you add another 2 pi, and you end up with 2 pi over here. Okay, now we are going to subdivide everything up. So halfway between 0 and pi, that would be halfway. That's pi divided by 2. So now you can look at these from 0 to 1 pi over 2, 2 pi over 2. Let me narrow this down just a little bit. See if it'll do it. Doesn't want to do it. There we go. Too much. Okay. So 1 pi over 2, 2 pi over 2, go another half, 3 pi over 2, 4 pi over 2, which is the same. What's 4 divided by 2? That is the same as 2 pi. So again, 0, half a pi, 2 halves of a pi, 3 halves of a pi, 4 halves of a pi. So think about fractions. Okay, so now I'm going to use green. I'm going to divide this. I'm going to divide it into quarters now. So if I start at 0 with the green, halfway between, right, half of a half is a quarter. So 1/4 of a pi, 2/4 of a pi, 2 pi over 4, that's the same as 1/2, 3/4 of a pi, 4/4 of a pi, which is the same as pi, right? So quarter, 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 right? 1/4, 2/4, 3/4, 4/4, 5/4. So there's 5 pi over 4, 5/4, 6/4. 6/4 is the same as 3/2. 7/4, and 8/4. 8/4 is the same as 2 pi. Okay, so now we have our other important measures, which are, let's do thirds now. Let's do thirds. So you're taking from 0, I'm doing this in orange now, from 0 to pi, that's 1 whole, right? 1 whole pi. We're going to divide it into 3. So it's roughly going to be 1, 2, 3. Okay, there's 1, right? 1/3, 2/3, 3/3 of a pi, Okay, so that would be 1 pi over 3, 2/3, 3/3. 3/3, right, is the same as 1. 4/3, 5/3, 6/3. 6 divided by 3 is the same as 2 pi. All right, now we have one last one left. Guess I'll do that in white. Okay, we are going to do sixths. We're going to divide that 1 pi up into 6. Maybe I can try to use another color. Let's do purple. Okay. All right, so we'll do purple for that. So we're going to divide it up into 6. So there's 1/6. So that's 1 pi over 6, 1/6 of a pi. 2/6, which is the same as 1/3. 3/6, which is the same as 1/2. There's that 6th right there. 4/6, which is the same as 2/3. 5/6, right? There's all those 6 pieces, right? 1, 2, 3, 4, 5, 6, and then 6/6. 6 pi over 6 is the same as pi. Now 7/6, that's that one. 8/6, 8 pi over 6 is reduces. That's the same fraction as 4/3. 9/6, that's the same fraction as 3/2. 10/6, 10 pi over 6, which reduces to 5/3. And 11/6. What's the last one? 12 pi over 6, which reduces to 2 pi. All right, so 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So these are the ones you have to know. These are classic for trigonometry. We have to understand degrees and radians. And I'm going to stop the video now. That's all I'm